Well, good evening. Let's see, as Bill said, he kind of took away my thunder about extension and who we are. So let's do a little, by show of hands, who knows what extension is? Wow, that's way more than we usually get. Okay. Probably due to the audience that we're in. So for those of you, a couple that didn't have your hands up, extension is part of the University of Florida, and my logo is kind of cut off there. But extension is part of the land-grant university mission. So the three parts of that mission are teaching, research, and then what I'm doing tonight, providing extension, sort of using the term to define itself, extending the reach of the university out into the community. So we have an office in every county in Florida. So our office here in Pinellas County is at the Florida Botanical Gardens over in Largo. And it's not just horticulture information, though. Extension provides food and money information. 4-H is part of extension. So if I put the big logo up there, the tagline in UF is Solutions for Your Life. So it really is information intended to help the residents better their lives. So that's my little thing about extension. Does anybody know how old extension is? What birthday are we celebrating? 35th? 100th birthday this year. Yeah, and so the land-grant university system was actually created 152 years ago now, I think. But this is our big year for us, celebrating 100. Extension as a nationally. Mm-hmm. Yeah. So this evening I'm going to talk about soil, and as Bill said, my background is in landscape architecture. I am not a soil scientist by any means, so this presentation came from our faculty advisors up in Gainesville. So, I know enough to give you kind of the 10,000-foot level on soil science, but if there's any real detailed questions, you're probably going to have to defer to try and find the answer out for you type of a thing. But, one of the first things they told me when I took this job is if you don't know the answer, don't make it up. So I'll be honest with you that if I don't know the answer, I'm not going to make something up and try and pull one over on you. So I kind of like that quote there. And then this one here came from FDR. And we sure are doing a lot of destroying our soil, I think, in some of our development practices, and I'll touch on that a little bit at the end. But so before we talk about soil, we should define it. So what is soil? To you, this is where you talk back now. Supportive life, okay. What else does it do for us? Skin of the earth, okay. So our faculty advisors define it as this: a natural body comprised of solids, liquid and gas, that occur on the land surface. So there's our skin of the earth. So that photo on the right is a typical soil profile that we might see in Florida. So you can see there's a couple of real defined layers there, and I'll show you a couple of more profiles that we would typically see here in Florida. So there, that top, looks like about 2 feet is very sandy material there, and that's pretty typical of what we'd see in Florida. If we look at that ecosystem, that looks like a pine flatwood. We've got some pine trees, some saw palmetto in there. So pretty typical of certainly the interior part of the peninsula and the state. We've got a few other types of soil that we would see in the peninsula, but that's generally kind of what we're going to see. And if you have questions, please stop me at any time. Yes. Well, it's going to vary. So the question is, what is that layer below the sandy layer typically going to be? It might be hardpan out towards the coast. You might have a layer of shell in there and then sand on top of that. Generally, though, the hardpan is going to be much further down. You're going to have a couple of very defined layers, kind of varying levels of organic matter and muck within there. And as we get a little further, we'll see a couple of different profiles. So there are 5 major factors that help to form soil, and I am going to have to refer to my notes a little bit because that's way too much for me to remember. It starts with the parent material, which is very simply, where did this soil come from? So it could have either come from the place where it is, or oftentimes this parent material is transported by some other process. So by air, water, ice. A lot of our parent material is moved around by glaciers and kind of transported at a very large scale by some other process. So next is the climate. So how do we think climate would help influence the formation of soil? What are we looking for specifically? Weathering, freezing. And in Florida, we have what kind of a climate? Humid, hot, moist. So the hot and the moist climate really sort of accelerates the decomposition of that parent material. And we'll talk a little bit more about later on how that also affects the organic matter in our soil. But that's, the fact that we have that hot, moist climate is really why we don't have a lot of organic matter in our soil, because the heat and the moisture really help decompose that organic matter very quickly. With the topography, we're looking at the drainage and the erosion that is sort of influenced by the lay of the land. What are we looking at with biological factors, do you think? Bacteria, plant animals. You think about burrowing animals, they're in there sort of mixing up the soil. You got bugs, you got bacteria, and certainly you have us with the way we're developing the land now. We play a large role on kind of how soil maybe is being deformed. And then time, it takes a very long time for soil to form on a large scale. We're looking at geologic time scale, certainly much longer than any of us have been here or will be here. So it really takes a very long time, or took a very long time for these soils to form. Yes? So looking at some more typical Florida soil, so that's kind of the soil that we would see in the center of the peninsula. So you've got, looking at almost 4 feet of pretty sandy soil there, underneath that couple inches of topsoil there. The entisol, which is our central ridge, so a little bit darker color there, kind of tinting towards the red. Utilisol, so there's all these different families, so that's what that first word is up there. So getting up into the panhandle, where we're going to see a little bit more clay, and we'll see some of the red clays up there in the panhandle. And then the histosol, which is typical of wetlands in the Everglades, so we would see this certainly down in the Everglades, and then up near Brooker Creek and Tarpon Springs, there's quite a bit of this particular soil up in that area as well, around Lake Tarpon. So in Pinellas County, we have the marl, which is that shell-based, so you'd have that shell hardpan down there with a big, very deep layer of sand on top of it, so going to have a little bit higher pH there than some of our other soils. So then the interior part of the peninsula, we've got the sand and the pine flatwoods. So that was that first picture I showed you, that real deep 2-foot layer of sand. So then the muck up towards Brooker Creek and Oldsmar has a pretty neutral pH. And then at our home sites, if you live in a newer, maybe a gated community, you don't really know what you have. And I'll talk at the end about why that is, but it's generally, that soil comes from the retention ponds, and then it's brought in and used as fill. So we'll touch on that at the very end, some of the challenges associated with that. So this is the general percentages of what the composition of soil is. So you have about 50% solids and 50% is open space left for air and water. So when we start to see soil compaction, and I'll talk more about that later on, we really start to lose that space in the soil for the air and the water. And it is so critical for our plants that they are able to get the air and the water from the soil. So when we look at classifying so this is that mineral percentage, we have 3 types of particles. You've got your sand, clay, and silt. So what we're looking at here is the relative size of these to each other. So the big yellow circle is the sand, and then the little blue circle is silt, and then clay is very, very fine. So these terms don't actually define the chemical makeup of these particles. It is just a size classification for the size of the particle. kind of important to note that. Anybody seen that little soil triangle before? So that is a way to classify the texture of soils. So in Pinellas County, we are down in that bottom left corner, pretty sandy. Some of our soils will go over into the coarse loamy, the blue area there, but mostly down in that bottom left corner is where we hang out. So how does the texture of our soil affect how much water and nutrients it can hold? So the picture on the left is what our sandy soil would look like. So the big brown shapes are the sand particles, and then the spaces in between are the pores. So we have macropores, large pores in our sandy soil. So that provides us with very good drainage, but a rather low water holding capacity, because the water tends to collect in those micropores, in the much smaller pores, which we see in our more clay-heavy soils. So they have poor drainage, but they have very good water holding capacity, and they also retain organic matter and nutrients pretty well. But clay soils aren't really ideal for growing vegetables either, so you need to kind of find a nice balance there between the sand and the clay. So to look at that another way, sandy soil, very poor water holding capacity, poor nutrient holding capacity, low in organic matter, it's prone to leaching. Yeah, they basically wash right past the root zone. So in ornamental landscaping, we're looking at runoff and leaching as the two ways that nutrients leave the landscape as pollutants. So the leaching is where the nutrients just run right past the root zone. So in Florida, it only takes about 3/4 of an inch of water to wet the top 8 to 12 inches of soil in our landscapes. And that's why getting back to the ornamental side, that's why the research we want to apply 3/4 of an inch of water to our grass and our plant beds when we water, because any more than that, and you're just wasting that water. So with our clay soils, kind of the opposite of that, very slow infiltration. The water kind of stands in that clay soil for a very long time. They have a very fine texture, get the high water holding capacity, and they do hold nutrients very well, but because they are so dense, plant roots don't really penetrate that soil as well as we would probably like them to. So a few of the chemical characteristics we are looking at in our soil, they're going to provide the nutrients needed for plant growth. Plants get the carbon, hydrogen, and oxygen from the atmosphere, but everything else they are getting from the soil. So it is our job to kind of help make sure that soil is going to provide all of the necessary nutrients. And then the pH of the soil is the other big thing that we are really concerned with. And I'll show you later on why a lot of problems, especially in fertilization, can be caused by not knowing what your pH is. So you can change the chemical characteristics of your soil, a little bit. You can add organic matter, and that certainly helps, and that's probably the best thing to do. We can add fertilizer to give our plants a little boost, and it really drives me crazy when we hear marketing talking about feeding especially our lawns. Feed your lawn, because there's a big misconception that the fertilizer is food, and you'll even see, they're right there, rose food. Right? Plants feed themselves through photosynthesis, so they take the sunlight, convert that into sugar. So you can think of fertilizer as a vitamin. So if all we did was eat vitamins, we would have a nice nutrient balance, but we wouldn't be very healthy. So you want to think about your plants the same way. You really need to make sure they're getting the proper amount of sunlight to do the photosynthesis, to feed themselves, and the fertilizer is just meant to really kind of balance out that diet, if you will. We can also add specific minerals to try and adjust the pH, but they're not a very good long-term solution. Generally, you want to select plants that are going to be happy with the pH that you have, instead of adding something to the soil every 3 months. perpetuity. You want to choose plants that are going to be happy where they're at. So the pH looks at the acidity or alkalinity of the soil, and you can get a soil test done. So if you really want to try and change your pH, generally you're not going to need to raise your pH in Pinellas County anyhow. I mean, our pH is going to be pretty much high enough, but if you wanted to try and lower it, you could add some type of sulfur to bring that pH down. So this is kind of interesting if you've never seen one of these, just looking at the pH of some everyday items. So distilled water right there in the middle at 7. Most plants are going to grow well in a range of pH between 5.5 to 7.5. Some of them want plants a little bit more acidic because these plants in particular don't use iron very efficiently. And I'll show you in a little bit how the pH really affects the availability of different nutrients. And that second bullet gets to the same thing. If you get a pH that's too high, some of the nutrients are not available either. Because you've got the pH along the top and the bottom there. So as you move to the right and the pH increases, as the width of these bars decreases, that shows that the nutrients are less available at the increased pH. So going the other way, you've got, phosphorus gets very limited right around 6. Talked about iron. You can see how iron at 5, 5.5, it really starts to get much wider. So that's why those plants that like that low pH, that are not very efficient with using iron, that's why they like that low pH, because it's very readily available at that lower pH. So kind of the effects of this that we see a lot in the ornamental side is people, maybe they don't really understand what their pH is. So let's say they've got a 7.5. So a few of those micronutrients are pretty limited there. So the easy thing to do is look at my plants. I've got a nutrient deficiency. My plants are kind of yellowing. I think I better throw some fertilizer out there and help them out. But when the real issue is actually the not understanding the pH and the kind of the limiting factor of that pH. So really important to at least have a general idea of what your pH is, and you don't need to know the entire landscape, and I'll talk about how to do soil testing more on the landscape side, but it still would apply to vegetable gardening as well, yes. So we've mentioned organic matter quite a bit. So that is the portion of the soil that was something that was once alive. So it's plant and animal remains, cell tissue of microorganisms, plant roots and critters, whatever they're secreting. When I talk about organic mulch in the landscape, I've had a few people ask me if we mean certified organic mulch, or so I want to clarify, we're just talking about something that was once alive when we're talking about organic matter. So this organic matter does a lot of great stuff for us. It increases the water holding capacity, helps kind of provide some structure to the soil, make sure we have those pores for the air and the water to get into. Helps with wind and water erosion, kind of makes the soil a little bit heavier so it's not going to blow away. Helps stabilize the pH, so you're not going to get real wild swings in pH if you have a good amount of organic matter. Provides support for microorganisms and beneficial bacteria. So we really want to work to increase the amount of organic matter we have. A few ways that we can do this. So some of these are a little bit geared more towards the urban landscape with the grass clippings and the leaves. A lot of people like to bag their clippings and leaves and send them away, but we do want to make sure we keep that material in our site. We really want to try and make our landscape as much like a natural ecosystem as we can. So if you think about a forest, there's nothing ever leaving that system. The leaves are falling, things are dying, things are creating waste, but it's all staying there and sort of feeding the soil. So in our urban landscapes, we've really sort of gotten into clipping and controlling things and removing stuff, and so we need to put more stuff back in the form of fertilizer. So you really want to try and let this organic matter work for you, keep it on site. So compost is another great way to do that. It can be compost you made yourself or something you purchased commercially. We're lucky that the City of St. Pete has the Soil Builder. That stuff is great. I use that quite a bit in my home landscape. And then the mulch, and that doesn't have to be a commercially purchased mulch. There's great sources of free mulch that we can use. We want to make sure that anything we put in as far as compost is well decomposed though, because if it's decomposing in the soil, it's robbing nitrogen from the plants. So you really want to make sure that you're not, having too much decomposition take place in your soil. Now there are some trench composting ideas. I've tested those out myself, where I had a square foot garden in the center row. I had just material that I was putting in there and composting. And I didn't plant anything in that center row, but the plants adjacent to that row were noticeably much larger and looked much healthier than everything else in the bed. And I didn't add any other fertilizer, so that was sort of a vegetable gardening fail. But yeah, that center row looked good, but I didn't plant anything right in that trench composting area. So there's all kinds of stuff at work. This food web, so what we're looking at is the bottom left corner is the organic matter that's sort of breaking down, and then kind of in a semicircle around that you have the first, we call first level consumers, so the really tiny guys that feed on that organic matter, and then the next layer around that, feed on the really tiny guys, and then just going up and up and up. So without having that organic matter to support that first layer of consumers, the whole insect food web sort of falls apart. And we know how important those beneficial insects are for us, so this organic matter is just another way to sort of help support that whole system. So imagine plants in the forest grow without fertilizer. So our goal should be to kind of try and recreate that as much as we can. Just leave what's in your landscape there. Unless you have, the other side of that house, if you've got a diseased vegetable, you don't obviously want to use those for mulch. So you do want to use some common sense. You don't want to use diseased plant leaves as mulch, because then you're just going to be sort of spreading that around. So, but if healthy plant material certainly can be used as mulch and compost. So our roots, this is where a lot of the oxygen exchange in the plants takes place. So there should be a lot of space in the soil for that oxygen. Important to note that roots do not pull solid particles through them. So we're waiting, particularly with fertilizer, we're waiting for those nutrients to be dissolved, to become water soluble, and then the roots are going to pull those nutrients up. So that's really what is going to determine kind of how, the amount of water soluble nutrients are going to determine really how quickly your plants use that fertilizer that you put out, or whatever your nutrient source. So when preparing to plant, so first we want to check the pH. Between 6 and 8 is optimal for most plants. So we don't test anymore at the Extension Service, but we do have I have the sheets that tell you how to do it. So we can still kind of help facilitate that process. And you can look at your soil and kind of generally tell if you have sandy soil, pretty much, unless you're in a very, very unique spot, or you have an urban soil, and I'll talk about that at the end. So in addition to that pH test, though, there's also a soil fertility test that can be done for a little bit more. So that looks at the amount of, I think, phosphorus, potassium, and a couple of micronutrients. So that's a good one to do if, especially if you're going to be planting a landscape, new garden beds, not vegetables. As, you really kind of want to know what your existing nutrient content is in that soil. If you are going to do a soil test, you want a bucket or a large container, some way to collect the soil. So what you want to do if you were planting a garden bed, the way we would do this, say the bed was the size of this room, you would take maybe 8 or 10 samples from random locations within the room, and then mix them all together in your bucket, make sure they were well mixed, and then send that one mixed sample. And that gives you a pretty representative idea of the soil conditions. Otherwise, you don't want to be sending 8 different samples up there. So that it's perfectly okay to kind of mix that soil together, get an average. Yeah. So if one of your gardens, I don't know, do you do raised beds or you do containers? So you could, you'd probably want to take a few samples from each raised bed and mix them together. I kind of touched on this too. So yeah, you could raise the pH with lime if you needed to, but you're really not going to need to here. But the best rule of thumb is just, figure out what that pH is and don't try and change it because you're going to be. So amending the soil, we talked about this organic matter quite a bit. You really want to, you want to amend your soil before planting. You don't want to plant your vegetables and then 3 months later decide, okay, I need to till in some organic matter now because that's going to tear up the roots. So you really want to do that before you plant. If down the road you decide you need to get some more organic matter in there, that's where you would look at, maybe mulching or putting a layer of compost on top and allowing that to decompose. Kind of talked about this water solubility of nutrients, really determines its usefulness. So in the landscape, what does our ordinance say? So I know this is sort of off topic, but what does the fertilizer ordinance say that we must apply as far as the amount of slow release? Does anybody know? It's 50%. Has to be at least 50% slow release in the landscape. That does not apply to vegetable gardens, though. So we generally, I think vegetable gardeners are more careful with their fertilizer. Okay, so I've been hinting at urban soils. So this doesn't really apply to vegetable gardening too much unless you were going to plant a vegetable garden in somebody's front yard without doing anything to it. But the typical development pattern here, we have this nice new home and we probably have a stormwater pond in the back there that person was sold as lakefront property. Right, we get that all the time. So they they strip the topsoil off and sell that to somebody else, and then they dig the stormwater pond and bring that nice mucky stuff in and put that down as the base layer of fill, and then the builder might bring in some more sand so we can see where they kind of maybe had a little bit left over and they spread that around. So you're taking the soil that was 20 or 30 feet below ground, maybe even more than that. Now you're bringing it up and mixing it up, and then we can see all the tire tracks in there, so that soil is very obviously quite compacted. So that's another issue that we see a lot in the urban landscape is homeowners dealing with compacted soil, and then sometimes the builder likes to bury concrete and construction debris in the landscape. So that's another thing that we see quite a bit. My parents bought a new construction home. It's about 10 years ago now. And my dad has a land clearing business, so he's got a bobcat and backhoe, but he took like 30 or 40 yards of construction debris out of the front yard that they had just left there. But the characteristics of these urban soils, you can see that's a profile that there's no real separation there. There's a little bit of a distinction between the layers at about 20 inches down, but pretty sandy, very compacted. Generally a little bit higher clay content. So a lot of our new development, you will, even though we're in a sandy location, one homeowner will have a little patch where they have very poor drainage, and then right next to that it drains like that. So people get very frustrated in dealing with these urban soils. You don't know what the nutrient content or organic matter is going to be because it's sort of a roll of the dice where that soil came from. Generally pretty high pH and not a whole lot of microorganisms or other beneficial bacteria in them. So the reason soil compaction is such a problem, so on the left we see the non-compacted soil, plenty of space there for water and oxygen. On the right, it's very compacted, so there's not a lot of space for the air and the water in there, and that very dense soil, it's very strong. It's hard for roots to penetrate that. And what often happens, so what probably happened with that photograph on the left, is they'll take that compacted soil and then they'll bring in 2 or 3 inches of loose topsoil on top for you to plant your landscape in, and so the roots are going to grow in that top 2 to 3 inches of nice fluffy soil, and they never go any further than that. So you can see the runoff taking place there right into the gutter. I mean, we've seen situations where turf grass had been down for 60, 90 days, and you could pull it right up. It hadn't even put roots down into that compacted soil. And then trees, that tree on the right, we're showing there that it's very stunted growth. Trees in these urban environments with the compacted soil just never really get as big as they should, or do as much as we would like them to. And that's soil from a 10,000 foot level. So this presentation was put together by one of my predecessors here, Pam Brown, with a lot of information taken from our state specialists up in Gainesville. So can there be too much organic matter? I don't think it would be an issue as far as plant health, but what you may find is if you had a lot of organic matter and it decomposed, then you're not going to have as much soil as you had. So you might have quite a bit of settling. So I don't know that that would be a problem in a vegetable garden, but in an urban landscape, it could be a problem. So the question is, are landscape companies going more towards edibles, like landscape designers? I don't know that that is mainstream yet with the landscape design industry. I was doing some freelance work for a landscape architect I used to work for a little bit, outside the county though. UF has done some work with edible landscapes. There's a demonstration site in Hastings, which is up by Palatka, where they have a backyard landscape that is done entirely with edibles. So they have instead of a viburnum hedge, they have a blueberry hedge, and then they have a couple of fruit trees in the backyard to create shade, and then they have some other, a lot of other vegetables in place of traditional landscape plants. So I think it is something that certainly Extension is looking at, and we'd like to go that direction, but it's not mainstream yet. To be honest, I'm not too connected with everything that's being done out there. At the residential scale, it's really hard to say, what's happening. But it is something I would like to, add to some of the classes that I'm teaching, to bring in some people to talk about that, because I think I'm at the point in my life where I think if I'm going to put work into something and put inputs and money into it, I need to get more than just something pretty to look at out of it. So it's certainly a personal interest of mine. Native plants are great. I love natives. But if I were doing a talk on Florida-friendly landscaping, the first principle is right plant, right place. So native or not, you still have to match the growing conditions, the conditions on your site with what that plant is going to need. So if you took a native wetland plant that wanted a shady, wet environment, and I put it in a dry area with full sun, it's not going to survive. It's native, but it's not going to do well there. So, really I think the most important thing is understand your site and the plants you're using, and then if you want to use natives, that's great. The Florida-friendly landscaping at the state level, we don't say only natives, but we certainly do encourage the use of natives for wildlife and all the benefits that they provide. Our website is pinellascountyextension.org, and we have all of our classes listed on there, not just the gardening classes, but everything. 4-H, we have energy conservation, responsible money management, so there's a lot of great information. So the question was about the copper and the algicides on the roof tiles, or roof shingles. I have not seen or heard of that being a problem. I haven't specifically researched it, but I haven't had anybody come to me and say anything about that. I've done a pretty good amount of research about water safety, but no, I haven't had an issue with that. In the using them for vegetable gardens, though, it is sort of a whole separate, there's a long list of caveats. Question is increasing water pressure in a rain barrel, some kind of a pump. Is the answer. Or you could get it higher. I've seen where somebody had it up kind of at their roof line, and if you wanted to, you could go that route. But Yes, well anchor it. Well, yeah, then you've got 500 pounds up in the air there. That you don't want that falling on you. So thank you for having me. I hope that this was helpful. And